Hi guys, so this video is about software design patterns. So in this video, we will discuss about what are different kind of design patterns available. So we have different category like creational patterns are there, structural patterns are there, behavioral pattern are there, right? So this video, I will only discuss like creational patterns, which is factory, builder, singleton, and prototype. Because if I will cover all the patterns, the video might become lengthy. So I will just cover creational pattern, and I will also make other two videos to cover structural and behavior pattern. And you can always give your feedback like what you didn't like in this video, so I can improve that in the coming videos, right? Just imagine like if any building is getting constructed, we need raw material, right? To build home, to build any building, we need bricks, we need cement, we need steel, we need other raw material, right? You are aware about oops concept, right? You are aware about abstraction, polymorphism, inheritance, encapsulation, which is a good thing. But now the next step as an engineer is to learn how to use it, where to use it, right? So you can create a robust software or a product or a code, right? And remember one thing, design patterns are guidelines, not strict rules, okay? Because some of the engineers get confused or they really try hard to fit design patterns even if it's not necessary, right? So if any design patterns are not fitting your use case, you can modify it, so you don't have to forcefully use the design pattern. So I just want to convey this point. It's good to have knowledge of design patterns, but if it's not fitting your project or use case, you can always modify, or you can always choose to go what is best for your project and use case. So let's start with creational patterns. So first one is factory. So in the factory pattern, right? So you can think of factory pattern like if you go in a real factory, right? They always have a centralized production of items, right? But when you go inside the factory, what you see is raw material and what you see is output, right? But what is being done with the raw material is at a centralized location, which is not visible to the outer people, right? All the people see, okay, they produce, let's say, box, so the input is paper and output is box, right? But how that paper is being converted to the box is not visible to the clients or not visible to the outer world, right? So same way in the factory pattern, we define an interface or method for creating an object, right? So if I go to the example, so I will open the factory pattern example here. So if you see here, right, so we have a logger class, right? So what we are trying to achieve here is like if you want to do any log, the log can be of different types, right? It can be console, it can be file, it can be database, right? So here what we are designing is, or what we are using is factory pattern, because here if you see, the first thing to use the factory pattern is always to use interface. Okay, so when you use interface, like in our case we have a interface, and we also call it as a product interface, right? Whatever product you are creating. So in this case, logger is our product and it have log method, right? Now the second step will be here to write the concrete product classes. So the logger can be of console logger, and I am overriding the thing, so I am using the polymorphism here, right? So if you see, we are using the oops concept, but we are using the oops concept in a way which will give us benefits and which fits one of the design patterns. And similarly we have file logger, similarly we have database logger, right? And inside this we will have some implementation of that logger classes, right? And then we should always have factory class here. The factory class will, what it will do, it will return the type of the logger based on the input, right? So here I am using the switch statement and I am using case. If this is the case, return this class. If this is the case, return this, right? If case is database, return database logger, right? And if I am returning some, if the input is something else, then throw an exception that that logger type is not available, right? So if you see here in the main method, what I'm saying is give me the logger of type console, give me the logger of type file. And if you will see here, if I will say logger of something which is not available, right? So let's run without first exception. So I will write, I will trigger the code. So if you see here, right, we have console logger, we have file logger, we have database logger, right? So similarly, if I will say here, let's say NoSQL, right? And if I will run this, so NoSQL is not present till now, right? So that's why it will give me an exception, unlock unknown logger type, right? So in this way, you can design factory pattern. If it fits your use case, you can use it. And to use that, you should have a product interface, you should have a concrete product classes, and you should have a factory class, right? And by doing this, what we achieved is we achieved encapsulate object creation within single method. So dependency inversion principle, that is loosely coupling or using the abstraction because we use interfaces, right? Open clause principle, that means new type of logger can be added, right? In our example, without impacting the existing loggers. So if I have to add a new logger of NoSQL, I can add it here and then I can use it, right? So it will not impact the existing code, right? So that's why we achieved open close principle. Second one is singleton pattern. So we all know like singleton class we use, right? Especially to make the database connections. So singleton pattern is like at the global level, you will have only one instance and everyone will able to access that instance, right? So it is being used when you want to create a database connection, right? So you don't want to open connection again and again, right? So when your application starts, you want to create a singleton database instance, and then anywhere you want to do any database operation, you fetch that database instant and do your queries and all other stuff, right? So this is known as singleton pattern. And to achieve the singleton pattern, right, so basically you need the private constructor and you need static method, you need static variable, right? So if I go in the code level here, so you will see, so you will see here like, and also most of the times you might get a question from interviewer like how to create a singleton class, right? So to achieve a singleton pattern, right, so first you should have the private constructor because you want to prevent the instantiation outside, right? So you don't want anyone to instantiate this constructor or class, right? So that's why the constructor should always be private. So basically this will hold the single instance of class. Wherever you want to get this instance, right, you should have a public method get instance. And here we are checking if instance is equal to null, right? So that means that instance have not been initialized yet, right? So then you create a new singleton, else return the same instance, right? So what we are doing here is, it is also known as lazy instantiation. So once your application runs and deployed, right, this instance is still empty until or unless the first call happened to get instance, right? Then only it will get created. And after the first call, second, third, and the subsequent calls will use the same instance, right? So this is known as lazy instantiation. But sometimes on the application deployment, or you want whenever my application will get built, right, or starts, I want that instance to be created right away. I don't want to wait for the first call, right? And then what you can do, you can here directly create new singleton, right? So this is you are converting to eager instantiation, or some people call it as early instantiation also, but eager will be the right way. But eager will be the right word. So as soon as your application will start, it will create the new singleton, and here you can comment this line, and then it will return the instance. So if I will remove this, right, so let's say if I run this with this example first in the main method, so what I will say here, system.out creating first instance, right? And then here what I will write, fetching instance, right? So if I will run this one, so you will able to see first when we did get instance, right, the creating first instance will get print out, right, because instance is null, right? And then it will call new singleton, and then it will call the constructor. That's why you will see singleton instance created, and then it will say fetching instance. And then singleton 2, it didn't went into the if block, it directly went into fetching instance. And then both the instances are same because we are here comparing both the instances, right? And if you see here, if I will do here new singleton, right, and now if I will run this application, then you will see as soon as I run this, the first line printed is singleton instance created, right? So that is known as eager instantiation. And then when we are doing get instance 2 times, it will not go into if block because the instance is not null, right? So it will say fetching instance, fetching instance. So that's how you can achieve eager instantiation also. And if you don't want eager instantiation, you can use a lazy instantiation. But this is overall concept of singleton pattern. Now what we achieved, right, we achieved reduced memory usage and we achieved granted one instance, right? So these are the things we achieved by using the singleton pattern. And if you want to relate it with the real use case, like, right, so you can think of a singleton as a single shared resource like a central government. So there will be always one central government at a time in a country, right? Similarly in software, singleton manage shared resources and provide coordination. So the best example is database connection. So the next one is builder pattern. So builder pattern basically is a design pattern which provides a way to construct complex object step by step, right? So it separates the construction of a complex object from its representation. And what we and the biggest use case for builder pattern is like video game character creation or meal creation, and how it is getting created. So let's see in the code example. So if I go here in the builder pattern example, so you will see like to create a builder pattern, right? So if you see here, we are creating a computer object using a builder, right? So what we are saying is create a computer and put the hard drive HDD as 500 GB and RAM as 8 GB, right? And then we are setting the additional properties, set graphic card enabled, set Bluetooth enabled, and then we are calling dot build, right? So you would have seen this kind of builder method if you're into Java and Spring Boot, where you used to, use other libraries in which they are using the builder pattern, in which you can create any object using that, right? So first thing is it is providing the code readability, right? So the by reading the code itself, I am aware that we are building a computer and what are the properties of computer object, and it is also providing me the encapsulation, right? So separation of concern means when we are building this, right, internally we don't know like how it is getting grouped up together, right? And we don't need to know also. So our target is to create a computer object. Internally we are separating and doing our own logic, but the final object, the user will get computer with whatever properties he is setting here, right? Single responsibility means this computer builder have only responsibility to build the computer. If we want something else to be built, then it will be a separate builder, so that computer builder doesn't have any responsibility apart from building the components of the computer, right? So that's why it is known as single responsibility principle. So how to achieve that, right? We have computer class, and here if you see, right, so we have getter method, right? But the constructor is private because we don't want that anyone to access this computer class, right? We want them to access the computer builder or use the computer builder, right? So you will have a class, but you will have the constructor as private. So you will have constructor as private, so that we are enforcing object creation through builder, right? So inside this private constructor, we have all these four properties, right? And we are having the computer builder as an input. And now we have a static class computer builder which will be used and which we want the people to use, right? We don't want them to directly use the computer constructor or computer class. We want them to use this computer builder. And if you want any other builder, you can have other builder class, right, inside that. So inside this, if you will see, we have a required, we have a optional parameters, right? And whatever is required, we are putting it in the constructor. So in the future, if you want to add one more required parameter, right, you can add it here, so that whoever is using this builder component knows like whatever is in the constructor, because without this parameter, constructor will not work, right? So they have to pass this. And then they have setter methods for the optional parameters. So they can set graphic card, they can set Bluetooth enabled, right? Inside this, the implementation is to set these private booleans, right? And then we have final build method, right? So build is returning the new computer, this, which will eventually create the computer with the properties, right? So this is how we are creating a builder pattern here. And if I will run this program, you will see whatever we are sending in the computer builder, it will get print with the help of getter methods. So this is how you can create a builder pattern, and I think it's really useful if you are building any restaurant application, right, to create a meals. And then if you are having the video game or graphic project, right, in which you have to assemble different icons, properties, and build some character, right? Then you will add weapon, right? In this case, we are adding RAM, graphic card. But if you're, let's say, if you would have played any game, right, in which you assemble the character, you will add the weapons there, you will add the accessories, clothes, right? So that's why you're building the character. For that type of application, builder pattern is really useful. And the last one is prototype pattern. So prototype pattern, as the name suggests, right, we are creating a prototype, or you can say we are creating the clone of the object, right? So cloning means in the coding level, right, cloning means copying the exact value of the object property without writing explicit code. And cloning also will be of two types. So one is known as shallow copy and one is known as deep copy. So shallow copies creates the new instance, but the memory of the original object and the clone object share same reference. So that way it is known as shallow copy. If a nested object is modified, the change will be visible in both the original and the clone. So it depends on use case. Like in some use case you need to do shallow copy, in some use case you want to do deep copy. And in the deep copy, both will refer to the different memory location. That means they will be independent. If the clone object is getting changed, it will not impact the original object. So that is known as deep copy. So this is very useful in graphic design application, because if you would have used Canva or other application, right, you just click on copy, click on paste, so whole element or picture or object is getting cloned, right? So that's why it is a very use case. And how to build it? So this is like a general structure of building the prototype pattern. So we will have one interface, right, prototype, and then we will have a concrete prototype 1, concrete prototype 2, and we will have a client here. So if I show you in the code example, you will be able to relate it better. So I will go to the prototype example, and here we will just show the shallow copy, but clone copy is also similar concept. So here I just want to show how I did this one. So we are creating one interface prototype which is extending clonable, and I have one clone method inside, right? So let's say I have a circle class, so I'm using implementing that prototype, and inside that I am overriding the clone, right? And I am saying super dot clone, which is the easiest way to do shallow copy. So what will happen is, in this use case, the use case which I am showing you, it is basically all the shapes can have some prototype to start with, and then it can be built over it. That's a prototype registry here to manage the prototype. So this is also a good way of doing it. So that in the main method, right, in the main method, if you see here, prototype registry, and I am registering one circle prototype, right, with the radius 5, and I am saying add prototype in the registry, right? So now if so I have already have one circle prototype, then this circle prototype can be cloned, right, in any way, like clone circle, right? And then you will see get radius is there. So if I will run this, so you will be able to see radius of clone circle 2. So in the similar way, right, you can also have like a different prototypes, right? So I can say here circle prototype 2, right, of radius 10. And then so you can think similar, like when you go to designing a video character, right, web graphic character, you already have something to start with. So that's why we call it as a prototype. So I am saying here, if someone wants circle prototype 2 with radius 10, right, they can also do that. So I can say circle 2 here, right, and I will add this. And if I go here, I can also say I don't want circle, I want circle 2, and now if I will run, right, it will give me the radius as a 10, right? So this is like how you can add so many options in the registry. You can also add different shapes, right, different things, and in your real implementation you can choose either one of them to get clone and get the properties of that, right, and then use that thing. Let's see this example for deep copy, right? So here what I have done is I've added new int array of dimensions, right? And what I'm doing is I am using again dimensions dot clone, and then I am returning the clone, right? So this is known as deep copy for the array, so that we are not using these dimension whatever is there, right? So we are doing the deep copy for the dimensions array, so that it will, once the dimensions are modified, right, it will not impact the original object. So here if you see, right, so we have a circle prototype, and I'm giving dimensions at 1 to 3, and we have other prototype 10. Here I have dimension 4 5 6, right? So now I am getting the circle 2, and I am getting radius, and I'm getting dimensions, and then I am changing the dimension 0th index to 9, right? So I'm changing of the clone circle. So if I run this one, right, so you will see when I'm changing the dimension, right, the dimension will be 956 instead of 456, right, which was in the original, and the original is not getting impacted with this statement because of the deep copy concept. So that's it for this video. So hope you understood the factory pattern, builder pattern, singleton pattern, and prototype pattern, and in next video we will cover structural and behavior pattern. So if you found this video helpful, don't forget to like, subscribe, and hit that bell icon for more programming content.